Hello and welcome to SAM online class. This is Dr. Subrat Kumar Mahanti. Friends, today we shall discuss about Nick translation. Nick translation is a tagging technique which was developed by Peter Rigby and Paul Berg in 1977. This technique uses two different enzymes. One enzyme is DNase 1, other enzyme is DNA polymerase 1. DNase 1 is the enzyme that introduces a small single-stranded break in only one strand of a double-stranded DNA molecule. DNA polymerase 1 is another enzyme which has two activities. One is 5' to 3' exonuclease activity and the other is 5' to 3' polymerase activity. So in Nick translation, by using the enzyme DNA polymerase, some of the nucleotides that are present in a DNA molecule can be replaced by their label analog. This is the principle of Nick translation. So Nick translation uses two different enzymes. One is DNase 1, other is DNA polymerase 1. Friends, this diagram clearly describes the process of Nick translation. This is a double-stranded DNA molecule which is unlabeled. First of all, this double-stranded DNA molecule is treated with the enzyme DNase 1. DNase 1 introduces a small single-stranded break in only one strand of the DNA molecule. So this is the small single-stranded break which is also known as Nick. This Nick has been introduced by the enzyme DNase 1. So by creating this Nick, you see here there is a free 3-hydroxyl group. So this 3' end can be extended by using the enzyme DNA polymerase 1. So DNA polymerase 1 through its 5' to 3' exonuclease activity can remove some of the nucleotides present in this stretch of DNA. So in this diagram you see here there are some nucleotides. These nucleotides are already removed by the exonuclease activity of DNA polymerase 1. After this, DNA polymerase extend the 3' end by adding new nucleotides. So in this last diagram, you see now the 3' end has been extended by the enzyme DNA polymerase 1. The enzyme DNA polymerase 1 catalyzes these two reactions. One is exonuclease reaction and the other is polymerase reaction simultaneously. So by simultaneously exercising these two activities, DNA polymerase 1 is able to replace the existing nucleotides by their labeled analogs. So these are the nucleotides, some of which are labeled. So by incorporating some of the labeled nucleotides during polymerization, DNA polymerase 1 is able to introduce radioactivity to a double-stranded DNA molecule. So after this, there is a small nick. So this small nick, finally, it can be sealed by using the enzyme DNA ligase. So for radioactively labeling a DNA molecule, some of the nucleotides present in the reaction mixture must be radio-labeled by incorporating phosphorus 32 at the alpha position of nucleotides. So friends, this is the process of Nick translation. So in the process of Nick translation, DNA molecules can be labeled so that they can be easily identified. So DNA molecules can be labeled by using a suitable fluorophore, or it can also label by using a antigen. If antigen is used for labeling, then it can be detected by immunodetection. Similarly, the DNA molecules can also be labeled by radioactivity. Radioactively labeled DNA molecules are frequently used as probes. And you know that probes are useful in various blotting techniques. For example, southern blotting. So the process of NIC translation has several applications. First is NIC translation is useful to create probes, and the probes are useful in fluorescent in situ hybridization. This technique is also useful in different type of blotting techniques and also in radio labeling. Friends, this is about the process of NIC translation. Please like and share my videos, and also please subscribe my YouTube channel known as Sam Online Class. Give your comments. Friends, your comments are very important to me, because on the basis of your comments, I will be able to rectify the errors. See you friends. Thank you very much. Bye bye.